All right, so our last lecture series looked at the nutritional components of health and performance. Now we're going to be moving into the exercise component. The first part of exercise that we're going to look at is the cardiovascular component. So cardio for short, we're going to look at basically the effects that aerobic training or cardiovascular training has on your health and performance, looking at both a physical perspective and a mental, cognitive perspective. So first, what is cardio? Cardio training or cardiovascular training is exercise that is performed with the purpose of developing your aerobic fitness or your aerobic capacity. Basically, your heart is pumping oxygenated blood throughout the different cells of the body. The more robust this whole system is, meaning that the strength of the heart and the ability to pump blood and to deliver oxygen at a maximal rate is going to ultimately improve health and performance in some capacity. So aerobic fitness again refers to that heart's ability to pump oxygenated blood to the muscles. So there's a bunch of different types of cardiovascular training. Here I have some of the most common ones. Typically, when we talk about cardiovascular training, we talk about a constant, moderate intensity type of training. A lot of times, though, also we have other types such as like interval training, and we'll discuss that a little bit later on in this lecture. But typically, cardio is referred to as like a moderate level intensity done on a variety of different modes, such as walking, rowing, stair climbing, jump rope, swimming, cycling, jogging. These are all some of the main types. So what's the big deal about cardiovascular training? Well, the first is that cardiovascular training plays a key role in health and performance. And it results in several adaptations of the body. So here are a few of those. All of these things are going to increase. So cardiac output, this is the amount of blood that's being pumped out by the heart, is the cardiac output. Cardiac output is also, it's basically a result of heart rate and stroke volume. So stroke volume being the amount of blood that's ejected per beat, and then times the amount or the number of times that the heart is beating per minute. It's cardiac output. Oxygen uptake refers to the amount of oxygen that's being uptaken by the cells to be utilized. Blood flow to the active muscles is going to increase. Blood volume is going to increase. We're going to have improved thermal regulation. The mitochondrial size and density will increase. Oxidative enzyme concentrations will increase, and also the capillarization of the muscles will increase. So more capillaries to be able to deliver more blood. Now all the following will decrease. And keep in mind, these decreases are not a bad thing. These are all positive adaptations. So submaximal respiratory rate. This means that the basically your respiratory rate will be lower at a higher level of activity. So if you take an untrained person and a highly trained person, the highly trained person will have a lower submaximal respiratory rate. Rate of all-cause mortality decreases with cardiovascular training, so death related to any cause. Rate of cardiovascular disease goes down, incidence of type 2 diabetes, rate of total body fat, rate of colon cancer, breast cancer, osteoporosis, all decreased with cardiovascular training. So these are some of the main reasons why it's so important from a health and performance perspective. Looking at the effects, not just on the physical components like we just looked at, cardiovascular training also has some very positive effects on things like memory. Both acute and long-term cardiovascular exercise um, are two different strategies that can be used to improve memory. Acute exercise refers to like just hopping on the treadmill, for example, and doing a single bout of training. Long-term cardiovascular training or chronic training refers to, for example, 12 weeks of training. So it's basically a long-term program. Now, acute exercise, so just a single bout of exercise, can improve memory in a time-dependent fashion by priming the molecular processes involved in the encoding and the consolidation of newly acquired information. So essentially, this acute exercise will basically improve your ability to encode and consolidate new information in the brain. Now, long-term exercise, in contrast, doesn't have as much effect on memory itself, but it does provide the necessary stimuli to optimize the responses or the molecular machinery responsible for memory processing. So not quite as direct of an effect as acute exercise, but still positive benefits in terms of basically optimizing the machinery involved in memory processing. Now, strategically combining these two, so having a combination of both acute and long-term interventions, will likely maximize the benefits of cardiovascular training on memory. Now, cardiovascular exercise also has positive effects on something called executive function. Now, we discuss executive function much more in the next module, module 3. But executive function essentially refers to kind of those higher order thinking processes of the brain. So, for example, the ability of the brain to recognize incongruent stimuli would be one of the ways that we can measure executive functioning. One of the ways that we can test this in the lab is through something called an Ericsson flanker task. And the flanker task meaning that, let's say we take this image on the right, and I tell you to only look at the middle arrow. Now that middle arrow or that image is surrounded by two other images on each side, and these are designed to either be congruent, incongruent, or neutral. So if we're only looking at the middle one, we see that it's pointed left on the top image. It's incongruent because the other arrows have been given to point the opposite direction. For the congruent, they're meant to line up. With the neutral, it's not supposed to have any effect. So this is an Ericsson flanker task, and we can test things like reaction times to properly identify the stimuli. Now, this region of the brain that's highlighted in yellow here is called the anterior cingulate cortex. So this is a particular region of the brain that's heavily involved with aerobic or cardiovascular training. So with aerobic exercise, this anterior cingulate cortex is activated. And what's interesting is that some studies have even shown large increases in the volume of the anterior cingulate cortex, with aerobic training. Now, this anterior cingulate cortex is responsible for many autonomic functions. And it is observed to be more active in response to processing incongruent stimuli than congruent stimuli. And research on this suggests that acute bouts of cardiovascular exercise affect the neuroelectric processes underlying executive control through the increased allocation of neuroelectric resources through changes in cognitive processing and stimulus classification speed. Now, essentially what this means is that cardiovascular training, acute cardiovascular training, will improve executive function through a variety of mechanisms, and will enhance your ability to process information, complex information at a faster rate and be more accurate with it. Now, perhaps even more importantly, cardiovascular exercise can be very powerful for things like preventing metabolic disease, which we talked about in the health trends lecture as being a major health crisis. But can it be used as medicine? So this is a bit of a kind of controversial or debatable topic. Does it have medicinal-like effects? Now, for each disease, researchers Pedersen and Saltine in 2006, they did a review of research on the effects of exercise therapy on disease pathogenesis, on symptom-specific diagnosis, on physical fitness or strength, and also on quality of life. And I'll look at a variety of things that they looked at here. But this was a really interesting study that they did. So they went through a lot of different diseases and metabolic diseases, and they basically looked at the strength of the evidence that we have on exercise and being used as medicine. And what they found was that for insulin resistance, basically, for type 2 diabetes, we have very strong evidence for the pathogenesis, for the symptoms specific to the diagnosis, on physical fitness and strength, so improving fitness and strength, and also improving quality of life. So essentially, what this is saying is that exercise can prevent or treat symptoms and improve the quality of life for those with or perhaps at risk of developing insulin resistance. Very strong evidence. Looking at obesity, again, same thing. Very strong evidence across the board for obesity that it can be used similarly to medication. Type 2 diabetes, same thing. Very strong evidence across the board. Cancer, no evidence to suggest that exercise will prevent you from getting cancer. I think this is probably somewhat of a no-brainer. Cancer is really not necessarily related to you exercising or not. There's usually, some sort of an external factor that's involved, or possibly even some genetic components to it. However, as far as symptoms, improving fitness and strength and quality of life, there is moderate evidence that exercise, can have these beneficial effects. Depression, again, not saying that it's going to prevent you from becoming depressed. So it has no evidence for the pathogenesis. However, strong evidence for treating the symptoms, improving quality of life, and improving fitness and strength. Osteoporosis, strong evidence for the pathogenesis, moderate evidence for improving symptoms, fitness and strength, and quality of life. Dyslipidemia, strong evidence pretty much across the board, except for quality of life. There's only moderate evidence. Again, though, can be very useful. Fibromyalgia, limited evidence for the pathogenesis, but strong evidence across the board for everything else. Osteoarthritis, no evidence for preventing it from a mechanistic standpoint, but strong evidence across the board for symptoms, improving fitness and strength, and quality of life. So, essentially with all these, I didn't go through every single one of these. If you want to go through every one that they looked at in the study, there is a link to the study in the learning materials. Um, Now, the point here is that exercise certainly has medicinal-like effects. Can it replace medicine? No. It's not the same thing. Can it be used in combination? Sure. But the idea here is obviously we don't want to be relying on medication if we don't have to be. Exercise has very positive effects. The more that we can use exercise as a lifestyle medication, hopefully the less we will have to be relying on pharmaceutical medication. Now, again, not saying that it's going to replace it, but it still shows very strong effects, just like medicine does as well. Looking at some of the aerobic training variables. So if you're going to go to design your own program for aerobic training, what are some things that you need to know? The first is the exercise mode. So this is going to be what type of training are you doing? Are you swimming? Are you running? Are you biking? Training frequency. How often are you training? Training intensity. So how hard or how vigorously are you training? Exercise duration. How long are you going to train for? Exercise progression. You want to make sure that you're progressing. You're not just doing the same thing. If you just do 30 minutes of the same speed on a treadmill every day, you're never going to probably see much progression. There needs to be some sort of progress that's made in terms of any one of these variables. Maybe it's through increasing intensity, maybe it's through increasing duration or frequency. And also overload. You have to be providing some sort of an overload stimulus for your body to adapt. So how can we measure changes or aerobic changes through our fitness programs? There's a few very common ones. I'm going to cover kind of the main ones here. The first one is maximal oxygen uptake. This is also known as VO2 max. VO2 max is the greatest amount of oxygen that can be utilized at the cellular level for the entire body. In other words, this is the most, so the heart can only deliver so much oxygen to the working tissues, and the tissues can only utilize a certain amount of that oxygen. So this is the greatest amount that the entire body can utilize of oxygen at a given point. Now, another common one is the lactate threshold. If you've ever been running and you kind of reached a point where it became hard to carry a conversation, this is also known as the ventilatory threshold, and the ventilatory threshold is pretty similar and usually correlates pretty well with the lactate threshold. The lactate threshold is the percent of VO2 max at which blood lactate begins to accumulate beyond a point at which it can be buffered. So this is why you start breathing really heavily when you kind of go above that lactate threshold. It becomes hard to carry a conversation. Usually once you cross the lactate threshold, it becomes really hard to maintain that level of intensity. Now, heart rate recovery. This refers to how fast your heart rate recovers in a given amount of time, usually 1 or 2 minutes. So the question I'd like to ask here is, which one of these is most important when it comes to performance? And a lot of people might choose one of these and say, oh, it's definitely VO2 max, or it's definitely lactate threshold. The reality is these all look at different things. Now, if you had to pick a single variable to predict race performance, I'd say that speed at lactate threshold would be the best. And the reason is lactate threshold takes into account VO2 max because it's a percent of VO2 max. The speed that you can maintain at lactate threshold is ultimately going to be the maximal speed that you can maintain for a prolonged period of time. Taking into account speed also takes into account running economy. So if you were to have somebody who was a very, very highly trained runner compared to someone who maybe had great aerobic capacity but had very poor running technique or form, the person with good form is going to be able to outlast the person with bad form because they're more economical. So speed to lactate threshold would be the most predictive of endurance performance. Now there's some different types of aerobic training programs to look at if you're designing a program. The first is long slow distance training. So this is usually involving intensities of about 70% VO2 max, usually long durations, about 30 to 120 minutes, 1 to 2 times a week. Some of the main benefits from this would be enhanced thermoregulatory function, improved mitochondrial energy production, enhanced oxidative capacity, and increased use of fat as fuel. One of the main things that stands out here is the mitochondrial energy production. Long slow distance training is very good for increasing the mitochondrial density. And the mitochondria is where fat metabolism occurs, so this is where the Krebs cycle occurs. Pace tempo training. This is a type of training that's done right around that lactate threshold, or slightly above a race pace. Usually it's shorter duration, around 20 to 30 minutes, and you would do 1 to 2 per week. And the benefits would be improved economy and improving the lactate threshold because the runs are occurring right around the lactate threshold. Now we also have interval training. Interval training is usually done close to VO2 max. So this is at a very high intensity. Durations are usually 3 to 5 minutes. They can be as low as 20 seconds of work, or things like 1-to-1 work-rest ratios. Some that come to mind are like the typical Tabata protocols, which involve like 20 seconds of work and 10 on, or 10 on, 20 off, and 8 rounds. Usually you would do these like 1 to 2 times per week. Some of the benefits that you would see would be things like increases in VO2 max and enhanced anaerobic metabolism. And then lastly, we have repetition training. Repetition training occurs at greater than VO2 max. So this is an ultra high intensity, usually 30 to 90 seconds with a 1 to 5 work rest ratio, meaning that you go all out for that 30 to 90 seconds, and then you take a very long recovery, about 5 times what you worked. Usually only 1 time per week because of the very high intensity. But the benefits are improved running economy, improved speed, and improved tolerance for the anaerobic metabolism. And one more here. This is fartlek training. Fartlek training basically is also known as hill runs. This is basically where you vary between long slow distance and pace tempo training intensities. Usually 20 to 60 minute durations, and usually 1 time per week. And some of the benefits that you see are enhancements in VO2 max, lactate threshold, running economy, and fuel utilization. Now, interval training gets a lot of discussion. It's been suggested, for a lot of things such as being better for things like fat loss and being more effective from a time standpoint. So what is interval training? Basically, it's a method that is suggested to be more efficient, and it uses predetermined work-rest ratios. Now, the whole idea behind interval training is that you are able to work at a higher intensity than you normally could because you're taking some intermittent breaks. as opposed to just running at a set pace the entire time. You are running very, very fast, stopping, very fast, stopping. The idea is that you accumulate over the time you spend training, you accumulate more time spent at the higher intensity than you would normally without taking the breaks. So this chart here looks at using interval training to train specific energy systems. So we have three main energy systems in the body. We have the phosphagen system. We won't go too much into detail, so don't worry too much about this if you haven't learned this yet. But the phosphagen system is where we use phosphocreatine as a substrate. Usually the first 5 to 10 seconds of when you start working out, use this system. And you require usually 1 to 12 and 1 to 20 work-rest ratios. These are max power. If your exercise time that you're trying to train is in that 15 to 30 second range, a 1 to 3 to 1 to 5 work-rest ratio, and you can kind of go down the chart here just to try to figure out your work-rest ratios. So basically here, if you're a power lifter, doing 1 to 3 reps or so usually only takes about 5-10 seconds. You should then recover about 12 to 20 times that amount that you worked to fully recover that energy system. Now, if you're training more for long distance events, if you're like a marathon runner, but you want to use some interval training that's specific, using more of an oxidative interval training would be more specific. So maybe running at a higher intensity than normal for 3 minutes, but then using a 1 to 1 or 1 to 3 work rest ratio. So looking at some of the research here, is that high intensity interval training actually better than steady state when it comes to performance and fat loss and performance and things like that? So a study was done in 2015 by Foster and colleagues, and what they did was compare the effects of 2 different HIIT protocols compared to steady state. They did 8 weeks of training. They had 55 college-age subjects. The steady state group did 20 minutes at 90% of the ventilatory threshold. And then the first interval training group did a Tabata, which was a 20-10. They did 8 rounds, and this was at 170% of VO2 max. So this was like max intensity almost. High intensity training 2 did 13 sets of 30 seconds of work, 60-second rest at about 100% of VO2 max. And the results here suggested that although the high intensity interval training programs are more time efficient, they're not superior to conventional exercise training in sedentary young adults. They found actually was that all groups improved their VO2 max, their peak power, and their mean power, and that there were no significant between group differences. Essentially, it didn't matter which training style they did. Keeping in mind, though, that these were sedentary college adults, things could be a little bit different if you're like a highly trained athlete. So just keep that in mind. But the moral of the story here is do whichever type of exercise you prefer. If you prefer to go in, exercise all out and just do 10 minutes, high intensity interval training can be great for you. If you don't like that, if you prefer to just go in and just spend 30 minutes and do a little bit more relaxed training, steady state training can be effective as well. The point here is do the type that works best for you and that you like to do, because the type of cardiovascular training that you will do is going to be the most effective.